welcome back, everybody. Today's lesson is going to be on radical and rational exponents. How do we work between the two things? Vocabulary. Pause for a minute and fill this in. So according to the vocabulary in the diagram, if I'm looking at this 16, remember, if there is no exponent, it's a 1. And for the radical, if there's no number sitting over here on the pedestal, then it's an understood second root or square root, and they don't write the 2 there. So if we wanted to write the square root of 16 as a rational exponent, remember it's power over root or exponent over root. So the exponent is 1 and the root is 2. That's 16 to the 1/2 power. For the second one, our exponent is 6, and this tells us that our root, or the index of the radical, is 4. So power over root, x to the 6 over 4. Now remember, these are fractions sitting up there in the exponent. So we always make sure that we reduce our fraction, and 3/6 reduces to 3/2. So this note right here just shows you how we go backwards and forwards from there. Moving on to these examples. 25 to the 1/2 power. We start with our base of 25. We add our radical symbol. This is a first power, second root. So we can put the 1 here and the 2 here, but remember, we don't actually write those two things. So this is really just the square root of 25. Remember that evaluate means to find the answer. So what is the square root of 25? What times itself twice is 25? And that's going to be 5. 81 to the 1/4 power. Go ahead and put my radical symbol, and I have my base of 81. This is the first power and the 4th root. So we don't write that first power, but we do have to put the 4 on its pedestal to show the index of the radical, or what root it is that we're finding, the 4th root of 81. To evaluate this, we can do 81 to the 1/4 power in our calculator, or ask ourselves, what number times itself 4 times is 81? And that answer is 3. Number 3, when I have something inside of parenthesis, that means that that's part of our base. So we have our radical, and our whole base is -8. This is an exponent of 1, a root of 3. So the index of our radical is the 3rd root. And again, we don't write the little 1 there. What is the 3rd root of 8? -8. Sorry, the 3rd root of -8 is -2, because -2 times -2 times -2 is -8. 4 to the 3/2 power. So we have our base of 4. We put our radical symbol. This is an exponent of 3. We do write that. But the second root, or the square root, we don't put the 2 on the little pedestal. It's understood to be a second root if it's not there. Our base here is 7. Our radical symbol, we have an exponent of 2. And then our radical is 3, our root. So 7, the third root of 7 squared, is the same as 7 to the 2/3 power. And number 6, our base is 121. We put our radical symbol. Again, this is a first power and the second root. Well, this is an understood first power with the 121 and an understood second root or square root without putting the number there. What is the square root of 121? It is 11. Our rules. Go ahead, pause for a minute to fill in your rules. So let's start working on some examples. We have the indicated nth roots. Now remember, that n is here unless it's a 2. The a is here. And so for number 1, we have our radical symbol. We have negative 27 underneath here. And the 3 is our index, or what goes on our pedestal. The third root of the third root of negative 27. Remember, there's an exponent of 1 here, even if we don't write it. The negative travels with the 27 base, power over root. So negative 27 to the 1/3 power. I can type that in my calculator or ask ourselves, what number times itself 3 times is going to give us negative 27? And that answer is negative 3. Number 2, we have our radical symbol. Our base is 16, and our index is 4, the fourth root of 16. Remember, there's a understood 1 there for the exponent, so we can rewrite that as 16 to the 1/4 power. The fourth root of 16 is 2. This is going to be a positive 2 and a negative 2 because according to our rules right above, if you have an even root, which this is an even root 4, then you have 2 possible answers. Positive 2 times positive 2 times positive 2 times positive 2 is a positive 16. Negative 2 times negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4. Negative 2 times negative 2 is positive 4. And positive 4 times positive 4 is positive 16. So that is why, for even roots, your answers can be positive or negative. You try 3 and 4. All right, evaluating. Remember, evaluate means to find an answer. Number 5 is asking us to find the third root of negative 8. So we can write this. The negative is with the 8, so it goes in parentheses, power over root. So negative 8 to the 1/3 power gives us an answer of negative 2. Third root means it's odd, so there is only one answer, and that negative 2 is good. The difference from 5 to 6 is where our negative is. The negative on the inside here means that's part of our base. The negative on the outside says find this answer and make it negative. So we start with the third root of 8. Again, our base is 8. Our exponent there is 1, so power over root. 8 to the 1/3 power is 2, and then we make it negative. 16 to the 1/4 power. 16 to the 1/4 power. If I rewrote that in radical form, our base is 16. We do not have to put that 1 here, but you can. And then our index or our root is 4. But 16 to the 1/4 is what we use to put in our calculator what times itself 16 times. Or sorry, 4 times is 16. And that answer is 2. Now remember, we have to check about even roots. 4 is an even root. So since 4 is an even root, then our answer could be positive or negative 2. If we try to put number 8 in our calculator, sorry, this stuff shouldn't be there, negative 16 to the 1/4 power, you are going to get an error. It's going to say non-real answer. Remember, 16 to the 1/4, negative 16 to the 1/4 power, our base is negative 16 under the radical. The exponent is 1, and our index or our root is 4. This is asking you what number times itself, it has to be exactly identical, is negative 16. Well, since we have to have 4 of those numbers, and the only number times itself 4 times, that is 16, is 2, these are our only 2 options because they all have to be identical. So it's all positive 2 or all negative 2. Neither of these, when we multiply them out, which I did on the other screen, is going to give me a negative 16. And so anytime we have an even root with a negative base, the answer is not real. Now, lucky us, when we get into Algebra 2, we're going to learn how to do those non-real things. So that'll be exciting, something to look forward to when we get to that Algebra 2 class. All right, number 9, 16 to the 3/4 power. Sorry about all this stuff here, and let's move that stuff. That should not be on your paper. So we have a 3rd power and a 4th root. Well, I'm going to rewrite this a little bit differently because I don't think if I had to do this just in my head, I could do 16 to the 3rd power and then find the 4th root of that. So we can also write this as the 4th root of 16, take that answer to the 3rd power. We know the 4th root is 16 because we did it in number 7 and in the example number 2. We know that the 4th root of 16 is 2. And it can be positive 2 or negative 2. And then to the 3rd power, 2 to the 3rd power is 8. Negative 2 to the 3rd power is negative 8. And so this answer can be positive or negative 8. This last example, number 10, 27 to the 4/3 power. So we know that that is the 3rd root of 27 and a 4th power. 3rd root of 27 we've done before, and we know that that is 3. An odd root, we cannot do plus and minus. And then we do that 3 to the 4th power, which gives us 81. So that answer would be 81. Please do the U-tries of 11, A, B, C, and D. And this is where we are stopping for today. Thank you so much for joining me. I hope you've enjoyed your rational exponents. Have a great day.